So here we are in thinking about figures that are similar, and we want to kind of take what we know about figures and without just sort of looking at them and estimating, like, is it similar? I'm not really sure. It kind of looks like it might be. We want to be able to prove it one way or the other. So our directions here are we are going to determine whether the figures are similar. If they're similar, then we're going to give the scale factor of A to B. And then we'll show our work to prove our answer. So in this first example here, we have some information, right? So we know that this side here and this side here, if the figures are similar, will be corresponding. So we'll say this would be 9 and 12 from A to B. A comes first per our instructions up here. So then we can say, all right, let's compare it to another side length we have. Well, even though these are on opposite sides of the rectangles, in a rectangle, we know that every angle has to be a right angle in order for it to be a rectangle. And so that means that this side here and this side here are going to be the same length within that rectangle. So we can then compare our 12 in A to our 16 in B. All right, so we have A to B, and we want to know, are they similar, right? Well, let's find out. So one strategy you can use is you can simply simplify these. So if you use a diva and you simplify 9/12, you could say, well, I know I could divide them both by 3. So I can pull 3 threes out of 9, and I can pull 3, 6, 9, 12, 4 threes out there. I can do the same over here. So this is saying it's a 12 to 16. Well, I can pull 4, 8, 12. I can pull 3 fours out of 12. And I can pull 4 fours out of 16. Does 3/4 equal 3/4? Well, yes, it does. So in this case, cha-ching, we know that these are, yes, similar figures. And we know that the scale factor is A, 3, 2, 4. Okay, so our scale factor is 3 to 4, and it is similar. Let's try another one. So in number 7 here, we have two figures. They appear similar. Let's find out if they are. So we're going to, again, compare A to B. So as we do that, let's pick a side that is, in theory, if they're similar, would be corresponding. So let's call it a 5 to 3 situation here. We'll make it look familiar in fraction form. Come on. So we've got a 5 to 3. And over here we have a 5 to 7. But really, oops, I said it in the wrong order. We want to do our A to B. So we have a 7 to 5. And our question is, are they equal? Right? Are they proportional? So let's find out. Are these figures similar or not? So if we know that they're both, there's a chance at least, right? Because they're both improper fractions. So if we take what we know, right, about this fraction bar, it's just a division problem, right? So because there's not just an easy diva to divide both these numbers by, we're just going to divide 5 divided by 3. We can use a calculator, so we could do 5 divided by 3, and we end up with 1.6 repeating, and it ends in a 7. They kind of rounded it off there. Okay, and we want to know if these are similar figures, then this 7 divided by 5 will also equal the same thing. So let's find out. So we can do 7 divided by 5, and we end up with 1.4. Are 1.4 and 1.6 repeating 7 equivalent? Well, no, they're not. So these figures are, they are not similar. And we can actually write it by saying that they are not similar. So you can cross out, it's kind of very satisfying, cross out that equal sign because they are not equal. They are not similar in what would be their scale